Hello, everyone. I am between you and Fridge and Andy. So we'll try to do this speed talk. Who here has heard about vulnerability? Raise your hand. Just 1, 2, 3. Okay. Who has heard about reachability analysis? 1, 2. All right. Definitely few. Who hear about threat intelligence? All right. How do you mix them all? Are they even related to each other? Yes. The answer is yes. All right. So in my whole career, I've seen things. Who can recognize this quote? Yes. So from the title, the first joke is from the title, you would expect memes and jokes about Lord of the Ring, one surface to rule them all, and no. But in my career, I've seen things. I've seen vulnerability not being addressed. I've seen application security team, cloud security team fight with each other. I've seen CIO taking risk without knowing anything about that risk. So we're here to demystify a little bit of these things. As I said, I'm going to make and talk with jokes because cybersecurity is depressing enough. So let's have a laugh about it, about ourselves and the industry. And the first laugh, or not laugh, every presentation needs to start with about me. I've been in the industry for 15 years. I've been doing application security, cloud security development, and I've been having endless fight about vulnerability, about please, please, please fix these things. And the only time I actually managed to succeed is when I stopped talking about vulnerability and I started using data about this. You can argue with people, you can have opinions, but you can have opinions when you have data. You can have a view on data, but it's way more difficult to argue. And the whole conversation is about a data-driven approach. Now, I'm gonna talk at a faster pace that I normally talk because this is an hour-long conversation that have kindly been squeezed in 15 minutes. So I'm gonna power through this. Bear with me, we're gonna have drinks and then we're gonna unpack some of this stuff. So we're gonna have a walk back in the past, 2015 to today. What has changed? Why are we in this dire situation of mess where development team don't even understand which vulnerability we're even asking them to do? And then we're going to go to a solution to this kind of particular messy scenario. How do we address this mess of vulnerability? But most importantly, how do we empower management team and the rest of the organization to make risk-based decisions that actually mean anything to development? So back in the days, 2015, kind of monolithic application, attack surface was fairly limited, 15,000 vulnerability. Take it to today, that mess, if it loads, that mess. So application built with stuff taken out in the cloud, with libraries taken from somewhere, and security, please secure all that stuff. And the answer to that is, hey, you have this massive list of vulnerability and this massive list of misconfiguration and this open source stuff. Can you please do something, Mr. Development Team? And by the way, you're not paid for it and you're not measured for it. So the answer is no. And on top of that, I don't know, because of the more vulnerability that have been disclosed, more scrutiny, but we have roughly 20,000 vulnerability. And if you are in this journey, raise your hand. Good. If you have been at a certain point in time, I feel your pain because I've built massive programs and I've had to deal with this day in and day out. And believe me, it's not fun. So what I try to do is actually to automate a lot of this stuff and to make it relatable to the rest of the business. So my head and my neck was not on the chopping block, but their head was. But I empowered them to actually make data-driven decisions so that we didn't see too many head rolling, including mine. So, but if we take it to today, 2015, we had 16,000 vulnerability roughly, accelerate 33 times to today, 220,000 vulnerabilities, with just a very small increase of budget from a development community and from a defender community. So that purple line that you see up there is the opportunity gap of anybody downloading something and attacking your system. That is maybe internet exposing, maybe you have compensating control, probably not, because we've seen things popping. And if we see with this trajectory, in 2030, we're going to be to 1 million worth of vulnerability declared. And the curve that we see here is already been unproven. So the acceleration is actually much faster. Now, why is it that? Well, first of all, Mr. CTO from GitHub has said 50% right now of all of the software that is being produced with their code base. Believe it, trust it, using Copilot or not, because it's their Copilot, but AI is producing code. More importantly, anybody can have access to code right now and can produce code without any knowledge of what that means. And if we had a hard time teaching our developer CISP or any other security certification, try to teach that to any business analyst or business person. On top of that, we have malicious AI, because the AI that we produce is highly locked down, but the unlocked one is actually available out there, and developing exploits costs a fraction of what it used to be out there. That's why we have, from declaration to exploitation, 3 minutes on average, 15 days on the median in terms of from when something gets discovered and disclosed to actually getting exploited. Automation, easy of exploitation, it doesn't matter. We need to defend against those things. And this is from the latest Mandiant report. One of the things that is exploding is actually exploit of vulnerability, together with identity. But what I want to say is, has anybody seen, for example, the recent AWS exploits or AWS disclosure of all of the identity? Come from the movie Transfer, kind of exploitation, 2023. So not just because something gets exploited, it doesn't have an immediate ripple effect. So exploitation is on the rise. And despite identity and credential exploitation being a lot and one of the main drivers of exploits, by 2025, we're going to have the reversing trend of the green line down there, the exploitation, actually uptaking the identity misconfiguration. Now, I'm not saying go out and forget about identity, absolutely not, but kind of weight your score between misconfiguration, identities, and vulnerability management all together, because we need to secure a system that is composed by identity, machine, software. The main challenge that we have right now is that we are divided. And I've been on both sides of the world. Who is here in application security? Raise your hand. Very few. Well, Cloud Security Alliance, who is here in what I call environment security? So operation, infrastructure, cloud. Yes. Do you talk to your developer a lot? 1, 2. Very few people. And it's because of traditionally the two worlds were very divided, and application security and cloud security were divided. And the way we address this in terms of security is just running a scanner and then reacting to this particular vulnerability, or at least telling developer, please, can you fix this vulnerability? And sometimes this is a sea of problems, and sometimes they're not even contextualized. It doesn't even matter which one of those are. So doom and gloom. Yes, I know. That's why the dark slide. The question that we're trying to answer in vulnerability management and in all this talk is not how many problems do you need to address, but which one is the most important problem that's going to affect you and how important it is. So to answer the question, I'm not going to give you the silver bullet because I'm a practitioner, so I'm not here to sell flowers, but I'm here to sell reality. And it's hard. So on average, we're fixing things between 15 and 3 days. And the answer to push that number down that most of the business are doing is called SLA. Flat SLA, or service level agreement, or please fix this number of vulnerability by day X, Y, and Z. And it works 0% of the time. Gartner study, across all of the business units, none of them hit their SLA. Rationale is flat. It doesn't look at the things that you're fixing. You're going to breach, regardless of what you do, SLA, because you have more vulnerability than things getting fixed. So SLA is pointless. So what we should do is actually focus on what's really important. Not all of the CVE, but the one that can be weaponized, the one that can have a technical impact, the one that's going to have remote code execution, the one that are easy to be exploited and attacked and automated at scale. Start with those and work back. But if you apply SLA going to apply to that list of problems across the board without prioritizing in no way, shape, or form. So doom and gloom, yes, but there is a way forward. There is a light at the end of the tunnel. So how do we get there? So first problem first, that is not just in vulnerability management, but in anything that we do, who needs to do what, where? And then we're going to address how important it is. And it's challenging. Bear with me. This is how we build modern applications. So you have your AppSec team on the left. They're going to attach their application with code, build file, website, and API. They're going to build something. They're going to encapsulate that something in the nice container. They're going to deploy that container into an image registry. There is probably some more step in that path. And then they're going to scale that to all your cloud environment, cloud instance, and so on. So in that kind of scenario, all of these elements can have vulnerability or misconfiguration. Now, as an engineering team, who even owns this stuff? And can you even if you detect a vulnerability and you detect somebody that owns that stuff, can that person fix an image of a container that is running in production? By the way, answer is no. So to fix that problem, first of all, we need to fix one element that is called lineage, or tracing back where are those things coming and if we can do anything about it. And that's one of the problems that reachability analysis solves. That's why I like reachability analysis. The more important problem, though, is attribution. Who owns these particular things? And there are techniques to actually scale this, but require some collaboration with your dev team to actually tag these bloody things and attribute those things to themselves, because they're never going to be a magic formula that's going to automatically identify who the heck owns this stuff. And then tracing which application get built in which container and where those containers are getting run. So the 4 horsemen of the apocalypse is attribution, lineage, traceability, and reachability analysis. With this, if we defeat this, then we can get vulnerability management at scale, even in the cloud. So how do we do that? Well, it's a little bit more of a smaller picture, but it kind of brings the problem of reachability analysis to life. Now, on the left, you have a tiny open source project, Sankey YAML, that is unfixable and is built inside probably most of your application. It's getting built. You can detect it with your SCA. You can detect it with your SAST. You build it, you put it in a container that runs in your image registry, and then you run 1,500 times. From your scanner, you have probably 3 vulnerabilities being detected, multiplied by the number of applications, but 300 or 400 alerts from your image scanning and your cloud scanning. If you work with volumetrics, where do you focus? Left or right? Give me a number, give me a direction, left or right? On the one that is the massive blob of problem on the right, or the tiny little on the left? You should be focusing on the left, but you're practically focusing on the right, because the majority of vulnerability management program is actually focusing on volumetrics rather than risk. The problem is the things that is in there, you can't touch it, but the only way to fix that problem is actually fixing that library on the left. Now, the problem we've been discussing this, we spent 3 minutes. Any engineering team needs to reverse engineering that and identify and scale it, and that takes a lot of time to do. One of the things we do with Phoenix, we actually do that automatically. So detecting which library gets built where and maintaining the risk in the right path, because that's live risk, that's things that can get exploited because they're being built, but you can't touch it, so you should ignore it and you should fix somewhere. Now, there is another magic element here that is the magic one backlog that is just for the development team. This is the stuff that you have to focus, that is with the attribution, there is another problem that we solve. But this is why this part is hard. So some of this stuff you can automate, and then we can move into reachability analysis. So the element that I mentioned there, from container to the cloud, I jumped to one slide, but yeah, we can go here. Actually, I want to touch here. So you have different level of reachability analysis. So if you worked in this industry, you see the rage about reachability analysis. One big rage is because it works. It works for a particular category of things, for software being built somewhere. So that particular library being built in a container, you will never detect it with threat intelligence, you will never detect it with misconfiguration, but reachability analysis and traceability will give you, hey, this library is being built here, ignore here, is it actually running or not in a particular container? That's the information that you need to do something or not do something. Now, in the left side, you have another reachability analysis element that is called static reachability analysis to see if that particular function or library is even being loaded. That's a realm of application security. There is a whole range around the industry on static reachability analysis with some good and benefit, and we're going to get there as well with Phoenix. And then on the right side, you have all the reachability analysis, attack paths, threat intelligence like EPSS and evidence vector. That's going to drive all the operational risk. And is something even reachable down the path of attack? Yes, no, that's another reachability analysis or attack path if you want. And that's where you should apply things like EPSS or cyber threat intelligence. Who has heard here about EPSS? All right, how do you apply EPSS in a software layer? You don't. But there are CVE that are being published with EPSS. I'm part of EPSS. I'm one of the guys that built it originally back in the days of HSBC. We provide tons of data for that stuff. And it can't be applied to software. It can be applied just on one category of software, things that traverse the network, because the benefit of EPSS is detecting, have we seen that particular information and does it come from Microsoft, Adobe, or specific vendors? Those are the triggers that the EPSS AI algorithm is being built on. Those are the parameters. So if it doesn't detect on those elements, that information is more misleading than anything else. So apply the right context in the right asset. That's why EPSS, cyber threat intelligence, great at network level, crap at application level. That's why apply the right things to the right place is important. But also the risk of particular things change over time. Like all the discussion that we said right now that we've gone through is about traversing risk. Is, hey, is this particular library even being loaded, being used? Yes, no, that should drive selection or not selection of that particular vulnerability to fix. As that particular library being loaded in a container that is externally facing, all of these elements should drive risk. Now, all of this stuff is very technical, but risk is one. And you can represent risk at operation and at application and give that information to anybody in the executive team to say, hey, your bulk of application is at this risk level. The target for the organization should be at this one. Do something about it. That is how you convert a very high level subject to a very low level execution. And this is one of the things we do in Phoenix. This is one of the things that's been made effective at scale on setting risk target, not SLA, because risk target actually can get translated into a subset of vulnerability that should be resolved, while SLA are flat and tell you, hey, fix all of the vulnerability in your business application and your operational environment. So if you talk about cyber threat intelligence, there are 4 or 5 elements that probably you want to look at to prioritize your things and your vulnerability. If you start with the total number of vulnerability, you are around 220, 204,000, depending which filter you apply to the MVD database. But if you just look at the exploit available by bug bounty, 17,000 GitHub exploited vulnerability, you are already at 4%. So you are screening down already massively the number of vulnerability. CISA-KEV, GitHub verified exploit, that's something that we do with Phoenix CTI. You're already at 1,000 exploit, and then the hot vulnerability, the things that are traversing the network, the things that are hot in the wild, you go to 0.7% caveat. This applies to operation, things, machines, things that are running in the cloud, and few of the things that are in application security that are of particular category. things that can traverse in the network, like remote code execution stuff and others. And we're going to see some of these parameters in a second. And then the business criticality, the location, the reachability analysis, that's the last refinement that you do to actually get to a fraction of the total number of vulnerabilities. That's how you go from a mass like this to a mass like that. And then on top of that, you apply race-based decision-making. So not tons of vulnerability, but 100 vulnerability of which you need to solve 3, 5. Tell that to a development community that's probably more likely to listen to you and do something about it rather than, hey, you have 220,000 vulnerability and 5,000 misconfiguration on your cloud. Can you do please something about it? The answer is, please leave me be. Let me build things for the business. But if you frame it of, hey, you have 220,000 vulnerability, but only 100 are actually really important to look at for reason X, Y, and Z. And of that amount, you need to just look at 15 for next sprint or next couple of sprint. Probably the answer is, okay, we're going to look at 3, 4 story points every sprint, and we're going to do something about that. That's how you get action from engineers. So I'm going to skip this because we talked about exploitability in a second. We really talk about exploitability. So exploitability in itself is not just one single word, but it's actually composed by a number of elements. 0 day tells you some information if something going to get exploited later on. How popular is a particular exploit in the wild? Is this particular vulnerability exploitable and automatable? Do you have threat intelligence about it? And is this actively exploited in the wild? All of these form the information of, do I need to do something about this vulnerability to be exploited or not? And this is just a reminder of like reachability analysis, great in software, attack path, kind of great in the network with threat intelligence. Use the right tool in the right context because they can get you much further than just lip service. Now, just to give you a perception, can you detect why there is so many exploits for this particular couple of vendors, Microsoft, Oracle, Google, Apache? Yes. Yes. It's an economic factor. That's brilliant. It's an economic factor. Somebody's going to develop exploit, not for the laptop that is being deployed, the Arch Linux that is being sitting in the cabinet of some developer forgotten by light and God. But it's going to be that exploit that, for example, Omni and other people are targeting at scale. Somebody that everybody's using. Apple, more and more and more. Microsoft, because there are tons of Microsoft products and attack surface is wide. That's why with EBSS, we look, hey, which vendor published this vulnerability? If it's those top 3 or 4, then it's probably going to have more likely to be exploited in the wild, and somebody's going to make the effort to actually do that. And that's in the total number of exploits. If you look at the one that are verified, the one that have active exploitation is a subset of those, but still you see a pattern. And Oracle, because of Apache and Log4j, is the one that wins kind of the game. By the way, you can play around with all of these cyber threat intelligence on the website. We're a vendor and transparent on the data that drives, but also have fun with the data because I'm a nerd about data. So I published it. Now, you see the same pattern kind of in the vulnerability used in ransomware and the methodology used in ransomware. So I want to go quickly through that because it's important. Like 0 day and ransomware use the same methodology that are remote code execution and buffer overflow because those are easy to exploit. They are remotable exploit. They can be automated and deployed at scale. Now, there are some exceptions on those parameters, but the majority of it is a unit of economics. Like, can you deploy this stuff at scale? And CISA publish a yearly report on the top vulnerability exploited in the wild and the patterns that you can see in the wild. And again, remote code execution and buffer overflow are the one that are going to win the game because they're the one that, first of all, are easy to be observed. From a network perspective, you're going to have much more data on it. But more importantly, people develop exploit for it. And you see the same effect on the total vulnerability available in the national vulnerability database. You see kind of a flat division versus the one that actually have active exploitation methods. You see a massive difference. Remote code execution wins, and memory corruption in terms of impact of a vulnerability wins, or buffer overflow if you want. They have different names. This is AI. So we have an AI extractor of meaning. So sometimes the words are slightly different, but the effect is the same. Unfortunately, in vulnerability, we have a massive problem. There's a data consistency problem. And calling things with the same name is really hard, apparently, in our industry. All right, so how are we doing with time? We're out. Can you give me 10 minutes? 3 minutes. Okay. So how do we scale this? I mentioned it, data-driven approach, risk-based approach, setting risk target that deploy things at scale. You can do it yourself if you really want to, but I discourage it because I spend a tons of development time and money to actually develop these models and do it at scale, not even our own money, HSBC money. So, but if you want, feel free. Probability of exploitation derived by the data, the CTI, exploitability, if you have threat intelligence, if there is a fix available, and if something is reachable or not, and then the business impact of a particular vulnerability in your particular system. That's not us creating a new formula, that's international way of saying risk is risk. And that's context. So the way we do this is actually using a 4-dimensional risk formula that takes into consideration business criticality, the one on the left, what we call probability of exploitation, and then reachability analysis to bring in all of these contexts into one place and convert a lot of the stuff that I say today into just one number and then making a decision on that number. We have a maturity model as well, because who doesn't have a maturity model? But we help organizations going from reactive to proactive and acting on risk rather than reacting on vulnerabilities. And in conclusion, promise, it's not all doom and gloom. There is a method to the madness. There is a way forward. There is definitely a psychological effect of convincing all of the rest of your business to actually start moving away from critical and SLA into more risk-based approach. So it's a phased approach, but as soon as you see developers start working towards those objectives, those things sells by themselves. With Phoenix, we do this at scale. So if you want to talk with us, and we have a graph of relationship that really bring application security and cloud security together and help you developing these at scale and setting risk target that deliver real action for engineers into their backlog. Some of the latest features that we've done, including the contextual deduplication, that is one of the things that I'm more proud of, because it enables you to basically cut in 1 quarter your container vulnerability noise and your open source library noise. So I'm really proud of that, because our mission is reduce burnout in development community. Francesco, thank you so much for your time.